So we have our next speaker with us, Brandon Liu. Hello, Brandon. I can't hear you.
Hello?
Yeah. Yeah.
Okay, it's working now. Sound good?
Yeah. Hello, how
Awesome.
are you?
Doing well.
Yeah. So Brandon is from Protomaps LLC, and he would be talking about no two clouds are alike. So take it away, Brandon.
Are you able to see my screen share?
Yes, I can.
Okay, awesome. Hey everyone, I'm Brandon. I'm going to be talking about cloud storage today. For context, I'm working on a system called Protomaps. It's an end-to-end system for both packaging and styling maps using only static files. That includes geodata, that includes tile formats, that includes rendering. And it is cloud native from the ground up. It has a tile format called PMTiles that's being developed alongside it. And it's made of mostly open source components that are on GitHub. This is also in the context of a new product I'm starting to roll out called Mantle. It's a vector-based map product on your own cloud, built on Lambda or Cloudflare workers. And an important part of this is that it is vendor neutral. So it works the same way on Amazon or on Cloudflare and hopefully other vendors in the future. So a bit more about PMTiles. The idea behind it is kind of like cloud optimized MB-tiles, where MB-tiles are a SQLite container of ZXY tiles. These are agnostic to the actual tile content. They can be vector, they can be raster, they can be scientific data. It has an open source spec on GitHub. It has implementations right now for Python, for Go, as well as direct to the browser from storage. With Leaflet, I have a plugin for Map Libre, and I'm working on CB-Canoe output. And this is similar to other projects at this, there's other talks at this conference, like Kotar, ComTiles, TileBase. Same idea, which is a range-based indexed sort of archive container for tiles. So PMTiles is built on cloud native principles, HTTP 206, spatial indexing, and most importantly, commodity cloud storage. So what about cloud storage? I'm going to tell you what I learned from real world deployment of vector PMTiles on different clouds, not just S3. It also applies to other formats like FlatGeobuf, like COGs, like Copics. The challenge areas I'm going to briefly go over are around performance, security, and freshness. Performance, there's this quote, which is, don't underestimate the bandwidth of a station wagon full of tapes or shape files going down the highway. So that's one definition of performance, which is bandwidth. That concept of performance is usually not what we're talking about with cloud optimized. Optimized means low latency, not high bandwidth. Low latency enables Slippy maps, it enables interactive queries, it enables grabbing a piece of the data from the full data set. And one really important part of latency is HTTP version 2. Now that enables multiplexing where you can have many of these requests in parallel. But most vendors actually don't support HTTP version 2 on their base storage product. They usually reserve that as part of their CDN. Of the big ones, I think Google Cloud is the only one that has HTTP version 2 as a default. Byte serving plus compression. For vector formats, they don't have a domain-specific compression built in like PNGs or JPEGs. And partial content is incompatible with the default content encoding sort of gzipping of the web. Browsers don't support a general purpose decompression API yet. And multi-part ranges generally are not supported on cloud storage. Security. Serving files direct from storage to the browser is good. That's a really compelling use case, but that's CrossOrigin usually. And of the major cloud providers, not all of them allow multiple origins to be defined for cores. S3 allows it. Other storage providers only allow one origin or just the wildcard. And if you have the wildcard, there's this problem which I call the Nafter or Mapster challenge, which is that if you have range requests to download a part of the file, well, your users can just download the whole file. It's almost like Napster for maps. You can just download these data sets with no DRM. And that risks these runaway costs. If you're paying per gigabyte of egress, then anyone can just download the entire data set. It might cost $1 per user, but that adds up pretty quickly. There's no way to limit on these storage providers, only 206 range requests. And I think requester pays is a good solution, but right now that's very vendor specific. Freshness, even though cloud optimized formats are read optimized, the world is changing, the data does update. The convention is to just replace the whole file on cloud storage, and storage providers, they all implement e-tags. There is one e-tag string corresponding to each version of the file. And implementations and caches should use these e-tags to find out when a file is stale, to know that there's new data available. So specs can take advantage of this. Conclusions, performance, security, freshness should influence the spec and implementation of cloud optimized geodata. Cloud storage is widely varying in capabilities. It's competitive, it's evolving, and don't build for S3 only. Try to make your system work on other cloud providers. That's all I have. Happy to talk about this on Gitter. You can find me on Twitter, GitHub, or email. Thanks.
All right, thank you, Brandon. And Brandon would be around here on the Gitter for the chat and questions.